This is a Charles law question, a relationship between rate of diffusion and the mass of the molecule. Now, what's being asked of us is the molecular formula of gas G. We know that gas G has 78.16% of boron and 21.84% of hydrogen at a rate of diffusion of 6.45 milliliters per second. And we also have the mixture of this gas and, of course, carbon tetrafluoride. Under the same conditions, it has a rate of diffusion of 3.62 milliliters per second. Okay, here we have the relationship between rate and mass, Charles' law, rate of diffusion, where rate 1 squared over rate 2 squared is equal to mass 2 over mass 1. Now to get mass 2, we multiply mass 1 by the square of rate 1 over rate 2. Now we plug in our numbers. Mass 1 is 88 grams per mole, which is the molar mass of carbon tetrafluoride. And then rate 1 is the rate of carbon tetrafluoride over our unknown mass, which is 6.45 milliliters per second. And if we were to calculate this out, we get 27.719 grams per mole. And that is the molar mass of our unknown. Okay, we're going to take the molar mass that we received in the equation of the relationship between rate and mass earlier, and we are going to take the percentage mass we were given beforehand of boron and hydrogen. The percentage mass of boron in this molecule is 78.16%, and the percentage mass of hydrogen is 21.84%. And if we see the percentage for this molar mass, multiply this by this, we get 21.67 grams. Do the same thing for hydrogen, 21.84% mass of hydrogen, and this molar mass, 27.719. We get 6.1 grams. Okay. Now what do we do with this? Now I conveniently put the atomic mass of boron and hydrogen. So what we do with this is we take the molar mass of boron and the molar mass of hydrogen. Take this here, 21.67 grams over 10.811 grams per mole, and we get 2. So we have 2 boron, 2 boron atoms in this molecule. So we plug that in, we get B2. And we do the exact same thing for hydrogen. We take the molar mass of 1 hydrogen, 1.0079 grams per mole, and we get 6. And what we do here is we plug this in, so we have B2H6, and that is the molecular formula of the molecule, and that answers the question.